We're going to do several examples with the definition of the derivative, which I've got written up here. Keep in mind that this is just the slope. That's what we're calculating. This is the change in the y direction in the numerator, which is rise, change in the x direction in the denominator, but it gives us a lot of algebra to work through. Let's go ahead and look at our very first example. So for this first example, let's let the function be equal to, how about 3x squared? And I want to find the derivative. So I'm going to apply the definition of the derivative to x squared. So f prime of x is equal to the limit as h approaches 0. H is the difference in the x direction. And then I want to do f of x plus h. Well, f of x is 3x squared. So I'm going to plug an x plus h in to replace the x there. So I end up with 3, my input squared, that's going to be x plus h, minus just f of x. So I'm going to leave that as 3x squared, 3x squared. So what I've got up above here is, this is f of x plus h minus f of x. Sometimes that's the hardest part to do, all divided by, and we're going to leave that h. Our algebra really happens up in that numerator. So let's go ahead and start working out the numerator. I'm going to leave off the limit for now, and I'm just going to go ahead and take our algebra through. Now I need to square out the x plus h, so I'm going to do that with FOIL. So x plus h times x plus h. Nothing to do with the 3x squared. And then I've got that divided by h in the denominator, which is just going to kind of tag along with us. Let's get a little more room. Continuing to work through that algebra, let's go ahead and FOIL out that top. I get x squared. Inner and outer are both an xh, so I get plus 2xh. And then on the end, h plus h, that's going to be plus h squared minus 3x squared, and then that's still divided by h. My goal is to cancel the h in the end, so this is no longer discontinuous at 0. Next, we're going to bring that 3 through. So continuing to work through my algebra, I get 3x squared plus 6xh plus h squared minus 3x squared, and this is still divided by our h. Our goal is to cancel the h, and we're just about there. I can cancel these 3x squareds, so I'm only left with h terms. Let me bring the limit back in because I'm just about ready to apply that limit. So the limit as h approaches 0. In my numerator, I'm left with 6xh plus h squared divided by my h. Now I can go ahead and factor out an h in that numerator. So that gives me the limit as h approaches 0. I can factor the h out, and I get h, 6x plus h, still divided by h just for a second here, but I can cancel those h's now, and I'm left with 6x plus h. This is no longer discontinuous at 0, so I'm ready to transition over to direct substitution. So I'm going to go ahead and replace h with 0. If I do that, I end up with 6x plus h, which becomes 6x plus 0. So my limit, my derivative, is equal to 6x. This is the slope at any point along this curve. A couple ways that I can write this. So I can say that dx, so the derivative of my function 3x squared with respect to x, this really is the change in y in the numerator over the change in x in the denominator, is equal to 6x. We also found the derivative of this function, so we can use prime notation as well, is equal to 6x. Let's do another example. This time we're going to look for the derivative of the function 1 over x. Now I'm going to go ahead and pull out the f of x plus h and the f of x. Well, we already have the f of x, but let me go ahead and do f of x plus h. Sometimes I think it's helpful just to look at these guys separately. So I'm going to replace the input, so it's 1 over the input. This time my input is an x plus h. So that's going to go into my limit definition. As I am looking for that derivative, it is equal to the limit as h approaches 0. This is what gets us from two different x values to a single x value. So as h approaches 0, of, in my numerator, I need f of x plus h first, but that's going to be 1 over x plus h minus 1 over x. This is just f of x now. So again, I've got f of x plus h minus f of x. So x plus h, x. Okay, and the denominator is just our h. Now for this one, I've got a complex rational expression, which just means I've got fractions inside of fractions. So I need an LCD here. So my lowest common denominator is just a combination of all the denominators. So I've got an x plus h and I've got an x. So my lowest common denominator is going to be a product, x times x plus h. Let me rewrite what I've got because this is becoming a little bit messy. So the limit as h approaches 0. In my numerator, I've got 1 over x plus h, but I need to multiply everything by that common denominator. So this is going to be times x plus h. These are in a numerator. And then I've got minus the 1 over x also needs to be multiplied by that common denominator. I'm clearing fractions here, x plus h. And whatever I do to the top, I need to also do to the bottom to keep this guy balanced. So h also gets multiplied by that LCD x plus h. Now, my goal is to cancel this h in the denominator. So I'm not going to multiply anything out in the denominator. I'm just going to work with my numerator. In my numerator, as that was my goal, was to cancel those denominators. I can cancel my denominators. Let me give myself a little more room and we can keep working on this one. Okay, so continuing to work this guy through. So this is still a limit as h approaches 0. I'm also not messing with that denominator at all. So let's just leave that denominator all in white for now. So h, x plus h, leave it in factored form. But in my numerator, I've got an x left and a minus x plus h. So I have an x minus parentheses x plus h. I'm going to move that negative sign through. My goal is to have only h terms in the numerator so I can cancel the h in the denominator. That is what allows me to take the limit. So hx, this is just everything I'm not messing with for right now. In that numerator, I have an x minus an x, distributing this negative, minus an h. So I can cancel these x's, and I can also cancel the h, which is going to leave me with a -1 only in that numerator. So I end up with this limit, which actually is no longer discontinuous at 0. But let me go ahead and write what I've got. So -1 over x plus h. This is no longer discontinuous at 0, so I can switch over to direct substitution. And let's go ahead and plug in h equals 0. So I end up with -1 over x plus 0, which is equal to -1 over x squared. This is my derivative. So I can say that dx, my original function was 1 over x, of 1 over x, is equal to -1 over x squared. You could also write that as -x to the -2 if you wanted, or we can use prime notation. So f prime of x is equal to the same thing, -1 over x squared. Again, this is a formula for a slope at any point along the way. Let's do one more example. In this last example, I've got f of x equals 2x squared plus 3x, and we're going to find that derivative. So I know that f prime of x is equal to the limit as h approaches 0. And I'm going to go ahead and put my function in up on top. But I want to start by doing f of x plus h over here on the side. So f of x plus h is equal to 2 times the input squared plus 3 times the input. My input now is x plus h using my formula over here for my function. I'm going to go ahead and put in x plus h as the input. So x plus h, x plus h. I can even simplify it here, which I think is a really nice way to go, but I'm applying that function. As I apply that function even further, I end up with 2 times x plus h times itself. Whoops. plus I can distribute that 3 through 3x plus 3h. Okay, continuing to multiply this guy out, I get 2. I'm going to FOIL those 2, and that's going to be x squared plus 2xh plus h squared. And I still have the plus 3x and the 3h. Finally, I can distribute that 2 through, and I get 2x squared plus 4xh plus 2h squared plus the 3x plus the 3h. So many places you can make a little tiny error, so be really, really careful with your algebra. I'm actually going to need a little bit more room than what I've got here, so I'm going to rewrite it over here. What we just did was f of x plus h. Let's go ahead and write all of that over here. 2x squared plus 4xh plus 2h squared plus 3x plus 3h. And then I need, let me go back up to my definition here, and then I need f of x, which is my original function, 2x squared plus 3x. You can see this is so much more about the algebra than anything else. So I'm going to write now minus parentheses, 2x squared plus 3x, and this is all, of course, still divided by h. Now, because I'm so close here, I just need to distribute that negative sign. Let's distribute the negative sign in line and rewrite what this becomes. So as I distribute the negative sign, I get negative 2x squared minus 3x. Now I can go ahead and simplify what I can. I can cancel the 2x squared. Remember, your goal was to have only h terms, and this is going to work out beautifully. And I get the negative 3x canceling with the positive 3x. Okay, where does that leave us? I'm actually almost done. The algebra just takes so much work. Very, very tedious. I have 4xh plus 2h squared plus 3h, which is excellent. Only h terms left, all divided by h. Let's again give ourselves a little more real estate here. I am almost done. I'm going to factor out the h, so the limit as h approaches infinity. Factoring the h out of the numerator so I can do some canceling, just a little bit of canceling. 4x plus 2h plus 3 parenthesis, all divided by h still. And I can finally cancel those h's. So you'll see that my pattern is really consistent. I plug everything into the formula, I expand using algebra, and then my goal is to cancel out that h, so I do some factoring in the end. So I'm now left with something that is no longer discontinuous at h equals 0, so I can go ahead and use direct substitution. So as I plug this in, the 4x stays, we're just letting h be 0, so this is going to be plus 2 times 0 plus 3, and this is equal to 4x plus 3. So my derivative, the derivative that I was looking for, f prime of x, which is the derivative, d dx, of my original function, 2x squared plus 3x, is equal to 4x plus 3. Now you might be wondering if there is an easier way, and absolutely there is an easier way. This is using the limit definition. We're going to see the power rule next, which is a really nice, easy way to go. So be sure to check out that next video. Good luck, you guys. You've got this. Thanks for watching.